Hello and welcome. In this video, we'll understand table relations, why they are important, and how they help the system understand how data is connected. We'll use a simple example from our project, the LM Employees table, which contains employee ID and employee name. This table represents employees in our system. Now the real question is, how do other tables know that an employee exists, and how do they connect to this table? That's where table relations come in. A table relation defines a logical connection between two tables. It tells the system, this record belongs to that record. Without relations, tables are just isolated islands. With relations, they become a proper system. Before we talk about relations, a quick clarification. I have already created the employee table called LM Employee in the same way we created the leave request table, just to save time. For now, this table contains only two fields, employee ID and employee name. Later, this table could easily grow to include email, age, gender, department, and many other details. And this is exactly why we don't add employee information in every table. Because duplicating employee data everywhere would be a maintenance nightmare. So instead, other tables store only the employee ID, and all additional information lives in one place, the employee table. And the connection between these tables is created using relations. Now let's add a relation between our two tables. We have two tables, leave requests and LM employees. The leave request table will store employee ID. The LM employees table will store employee details. So the relation must be added on the leave request table, because that is where the reference exists. This is a very important rule. You always add the relation on the table that contains the foreign key. Now in the leave request table, go to Relations, right-click, and add a new relation. At this point, you'll notice two options. Relation and foreign key relation. A foreign key relation enforces database-level constraints. A relation is a logical relationship used by the application for lookups, validation, and navigation. We'll select relation for this tutorial. Once we add a relation, we get three options. Normal, field fixed, and related field fixed. Normal means the relation is based on matching fields from both tables. This is the most common type, and the one we'll use. Field fixed means a specific value on the current table is fixed. Related field fixed means a specific value on the related table is fixed. These two are used in advanced filtering scenarios. For our case, normal makes perfect sense. Now let's look at the relation properties. First, behavior properties. Create navigation property methods. When this is enabled, the system creates methods that allow navigation between related records. Very useful, and generally recommended. Use default role names. This lets the system automatically assign parent and child roles. Again, safe to keep enabled. Validate. This ensures that the employee ID entered actually exists in the employee table. Which means no imaginary employees taking leave. Now the data properties. Cardinality. This defines how many records are related. In our case, one employee can have many leave requests. But one leave request belongs to only one employee. So the correct cardinality here is many to one, from leave requests to employees. This is the most common relationship in business systems. EDT relation. This is used when relations are based on extended data types instead of direct fields. We'll leave this no for now. Entity relationship role. This defines the role of this table in the relationship. In our case, leave request is the dependent table. Name. This is the technical name of the relation. Give it a meaningful name so future you understands it instantly. On delete. This controls what happens when a record in the related table is deleted. For example, if an employee is deleted, what should happen to their leave requests? Options include restrict, cascade, or none. In our case, we do not want leave history to disappear. So we should not cascade delete. This is why association relationships are safer here. Related table. This is LM employees. Related table cardinality. This defines how many records exist on the related side. In our case, one employee record. Related table role. This defines the role of the related table, usually parent. Relationship type. This is very important. Now let's talk about relationship types. The relationship type defines how strong the connection is between two tables. If cardinality tells us how many records are related, relationship type tells us how tightly they are related. Let's start with the default option, not specified. This is often the default value you'll see. When relationship type is set to not specified, the system automatically tries to figure out the correct relationship type for you. It does this in a specific order. First, specialization. Then link. Then composition. Then aggregation. And finally, association. The system checks these one by one and picks the first one that matches the situation. So if the criteria for both composition and aggregation are met, the system will choose composition. Because composition comes earlier in the list. Now let's look at each relationship type. Specialization applies only to table inheritance. This is used when one table is a base table, and another table inherits from it. Whenever table inheritance is involved, the system automatically sets the relationship type to specialization. You don't manually choose this one very often. Next is link. Link is not a real relational relationship. It is mainly used for navigation between forms. For example, one form shows a list of records, and another form shows details for a single record. Link relationships require validation to be turned off. This relationship type exists mainly for upgrade and migration purposes from older versions. In normal development, you should not create link relationships manually. If you see one, it's probably from history. Now let's talk about composition. Composition is a very strong relationship. It means the child record cannot exist without the parent. For example, a room belongs to a building. A room cannot exist without a building, and it cannot belong to multiple buildings. A table can have only one composition relationship. If the criteria for composition are met, but you manually choose aggregation or association, the system respects your choice and does not override it. Composition is powerful, but also dangerous if used incorrectly. Next is aggregation. Aggregation means the child table is subordinate to the parent table. The child depends on the parent, but not as strictly as composition. The system infers aggregation in two common cases. First, if the parent table has a delete action defined using this relation. Second, if any foreign key field in the child table is marked as mandatory. If the criteria for aggregation are met, but you manually choose association, the system keeps it as association. Finally, we have association. Association is the most common relationship type. This represents a standard foreign key relationship. The tables are related logically, but deleting a parent record does not automatically delete child records. If the system does not infer any relationship type automatically, and aggregation or composition do not make sense, then association is the correct choice. In most business scenarios, including employees and leave requests, association is the safest and most appropriate option. So to summarize, specialization is for inheritance. Link is mostly legacy and navigation only. Composition is very strong and rare. Aggregation is moderately strong. Association is the most common and safest. Choosing the correct relationship type helps the system understand how your data should behave. And choosing the wrong one usually makes debugging very educational. Role. This defines parent and child roles in the relationship. Tags. Tags are optional metadata used for documentation and tooling. Now let's connect this back to our example. The leave request table stores employee ID. The LM employees table stores employee details. One employee can have many leave requests. So the relationship is many leave requests to one employee. The relationship type is association. And the relation lives on the leave request table. Once this relation is in place, a lot of things start working automatically. Lookups show employee names. Validation prevents invalid employee IDs. Navigation becomes possible between records, all without writing extra code. That's the power of relations. So to summarize, tables store data. Relations connect data. Cardinality defines how much data is connected. Relation types define how tightly data is connected. Once relations are set correctly, many things start working automatically. Which is exactly what we want. In the next step of our journey, we'll continue building on this and start adding business logic using classes. Thanks for watching, and remember, good relationships make systems stable too.